Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamualaikum warahmatullahi wabarakatuh. Today we are going to study the 9th standard science, first chapter, laws of motion. Introduction. The important points of this chapter are motion, distance and displacement, acceleration and Newton's laws of motion and related equations. Explanation. Motion of an object. We see the motion of several objects every day. Sometimes we cannot see the motion of an object directly, as in the case of breeze. Motion is a relative concept. If the position of an object is changing with respect to its surrounding, then it is said to be in the state of motion. Otherwise, it is said to be in the rest position. Displacement and distance. Suppose Sheetal is a girl. She went to her friend Sangeeta's house on her way to school. Prashant went straight to school. Both are walking with the same speed. Who will take less time to reach the school earlier? The person who went straight will go earlier. There is a difference between the actual distance and the distance travelled. We can infer that distance is the length of the actual path travelled by an object in motion while going from one point to the another, whereas displacement is the minimum distance between the starting and finishing points. Suppose a girl named Swarali walks around the edge of the circular field. She walked the distance, but displacement has not taken place. Therefore, even if the displacement of an object is zero, the actual distance traversed by it may not be zero. Speed and velocity. Speed is equal to total distance travelled upon required time. Speed is a vector quantity. The SI unit of speed is meter per second, while in the CDA system it is centimeter per second. Speed is related to distance. Velocity. The distance travelled in a particular direction by an object in unit time is called its velocity. Your unit time can be 1 second, 1 minute or 1 hour. The displacement that occurs in a unit time is called a velocity. Velocity is equal to displacement upon time. Displacement is scalar quantity and units are meter per second and centimeter per second. The unit of speed and velocity are the same. Velocity is related to displacement. If the motion is along a straight line, the values of speed and velocity are the same, otherwise they can be different. Effect of speed and direction on velocity. Velocity depends upon speed as well as direction, and that velocity changes by changing the speed while keeping the direction same, changing the direction while keeping the speed same, and changing the speed as well as the direction. The speed of sound in the dry air is 343.2 meter per second, while the speed of light is about 3 to 10 raised to 8 meter per second. Uniform and non-uniform linear motion. If an object covers equal distance in equal intervals of time, it is said to be moving with uniform speed. If an object covers unequal distance in equal time intervals, it is said to be moving with non-uniform speed. For example, the motion of a vehicle being driven through heavy traffic. Acceleration. You might have all played on a slide. You know that while sliding down, the velocity is less at the top. It increases in the middle and becomes zero towards the end. The rate of change of velocity is called acceleration. Acceleration is equal to change in velocity upon time. If the initial velocity is u and in time time t, it changes to the final velocity v. Therefore, acceleration is equal to a is equal to time velocity upon minus initial velocity upon time. Therefore, a is equals to v minus u upon t. If the velocity of an object changes during a certain time period, that it is said to have accelerated motion. An object in motion can have two types of acceleration. Number one, if the velocity changes by equal amounts in equal time intervals, the object is said to be in uniform acceleration. If the velocity changes by equal amounts in equal time intervals, the object is said to be in a non-uniform acceleration. Positive, negative and zero acceleration. An object can have positive or a negative acceleration. When the velocity of an object increases, the acceleration is positive. In this case, the acceleration is in the direction of velocity. When the velocity of an object decreases with time, it has negative acceleration. Negative acceleration is also called as deceleration. Its direction is opposite to the direction of velocity. If the velocity of an object does not change with time, it has zero acceleration. Distance time graph for uniform motion. Here, the graph of the distance and time is plotted over here with the time given as 0, with 0 distance covered, 10 seconds to cover the 15 meters of a distance, 20 for the 30, 30 for the 45, 40 for the 60 and 50 seconds to require the 75 meters of a distance, while the 60 seconds required to cover the 90 meters of a distance, and 70 seconds are required to complete the 105 distance. If an object covers equal distance and equal time intervals, thus the graph between distance and time is a straight line. Distance time graph for non-uniform motion. Here the distance is given and the time is also given. In this case, the time is having equal intervals while the distance is not equal. Here 0 requires for 0, 5 seconds require for 7 meters, 10 meters are required for 12, 15 are required for 20, 20 seconds are required for 30 meters and 25 are required for 41 meters, while the 30 seconds are required for the 50 meters and 35 seconds are required to complete the 58 meters of distance. Here the changes in the distance are non-uniform with time, thus the bus is moving with non-uniform motion, and in this case the straight line would not be available but it will be of any shape. A train is moving with a uniform velocity of 60 km per hour for 5 hours. The velocity time graph for this uniform motion time in seconds it is given, 0 for 0 velocity, 5 seconds for the 8 meter per second, 10 seconds for the 16 meter per second, 15 seconds are required for the 24 meter per second, and when the velocity will be 32, so it takes the 20 seconds. When the velocity increases for the 40 meter per second, so it takes 25, like that way 48 requires for the 30 seconds and 56 velocity will be there on the 35 seconds. So in this case the velocity time graph shows that the velocity changes by equal amounts in equal time intervals. Thus this is the uniformly accelerated motion. अब यहाँ पर जो है क्या है कि ये जो मोशन है यूनिफॉर्मली एक्सेलरेटेड है, इसीलिए इसका शेप जो है सिंपली आपके लिए क्या रहेगा, स्ट्रेट लाइन रहेगा, एंड दैट इज व्हाई वी कैन प्लॉट द ग्राफ इन अ स्ट्रेट लाइन. इफ इट इज नॉन यूनिफॉर्मली एक्सेलरेटेड मोशन, देन वी विल गेट द graph of any other shape, because the graph will be completely dependent upon the acceleration, that is uniform or a non-uniform. In such cases, we have to use the average velocity of the air in the given time intervals to determine the distance covered in that intervals. From the graph, the average velocity of the car is equals to 32 plus 16 upon 2 is equals to 48 is divided by 2 is equals to 24 meter per second. Equation of a motion using graphical method. Newton studied motion of an object and gave a set of 3 equations of motion. These relate the distance, displacement, velocity, acceleration and time of an object moving along a straight line. Suppose an object is in the state of motion along a straight line with initial velocity u. It attains the final velocity v in the meantime t due to the acceleration a, and its displacement is s. Therefore, the equation will be number 1, v is equals to u plus at. This is the relation between velocity and time. Second is the s is equals to ut plus half of at square. This relates the displacement and the time. Now here v square is equals to u square plus twice of as. This is the relation between the displacement and velocity. Let us describe all the type of 3 equation of a motion by the Newton. The change in velocity with time of a uniformly accelerated object. The object starts from the point, and if we draw a graph of its velocity, it is a straight line. The velocity of an object keeps increasing with time t and reaches to the last point. The initial velocity of an object is equals to u, and the final velocity of an object is equals to v time t. So therefore, change in velocity is equals to acceleration is equals to change in velocity upon time. Therefore, final velocity minus initial velocity upon time. From the graph, final velocity is equals to initial velocity plus acceleration into time. Therefore, v is equals to u plus at. Let us suppose that an object in uniform acceleration is a, and it has covered the distance s within the time t, and this distance is covered in the mean of a displacement only. Therefore, s is equals to ut plus half of at square. It is the Newton's second equation of a motion. We know that the graph of a displacement and velocity is a trapezium, that is quadrangle. So we can use the formula for its area, that is s is equals to displacement is equals to half of u plus v into t. Therefore, area of a trapezium is equals to half into sum of the lengths of parallel sides into distance between the parallel sides. But we know that a is equals to b minus u upon t. So this value we will substitute over here, that is t is equals to b minus u upon a. So therefore, s is equals to half into u plus b into b minus u upon a. When we open the bracket, we are going to get that b plus u into b minus u upon twice of a. Therefore, 2a will go there. with the s, so it becomes 2 of as is equals to b plus u into b minus u is equals to b square into u square. Therefore, b square is equals to u square plus 2as. This is the Newton's third equation of a motion. Now, uniform circular motion. Observe the tip of a second hand. The speed of tip is constant, but the direction of its displacement and therefore its velocity is constantly changing. As the tip is moving along a circular path, its motion is called as uniform circular motion. There is the rectangle in the figure. Place the tip of a pencil on the middle of any side of the square path and trace the path. Now repeat this action for pentagon, hexagon or octagonal path and note the number of times you have to change the position. If you increase the number of sides of a polygon by keeping change in direction, so therefore when an object is moving with a constant speed along a circular path, the change in its velocity is only due to change in its direction. Hence, it is accelerated motion. When an object moves with a constant speed along a circular path, the motion is called uniform circular motion. मतलब यहाँ पर क्या बोला है कि कोई भी ऑब्जेक्ट अगर सर्कुलर पाथ पर घूमता है तो उसकी मोशन को हम लोग क्या बोलेंगे, यूनिफॉर्म सर्कुलर मोशन बोलेंगे. जैसे कि एग्जांपल है आपका बाइसिकल या फिर स्लिंग की मोशन. नाउ लेट अस अंडरस्टैंड द यूनिफॉर्म सर्कुलर मोशन. If an object moving along a circular path of a radius r takes the time t to come back to its original position, in its speed can be determined by using the formula given by speed is equals to circumference upon time. Therefore, v is equals to, or the velocity is equals to 2 pi r upon time. Determining the direction of a velocity in a uniform circular motion. Take a circular disc and put a 5 rupee coin at a point along its edge. Make it move around its axis by putting a pin. When the disc is moved at higher speed, it will be thrown away. So similar way, when we will repeat this action many of the time, similar way the coin will be thrown away at the tangent. So that is perpendicular to the radius of a moving disc. So hence the direction in which it gets thrown off depends upon the position of the movement of changing at every point. Solved examples. An athlete is running on a circular track. He runs a distance of 400 meter in 25 seconds before returning to its original position. What is his average speed and velocity? Given total distance traveled is equals to 400 meter. Total displacement not given. We are supposed to find out. Average velocity we are supposed to find out. So therefore, average speed is equals to total distance covered upon total time taken is equals to 400 upon 25 is equals to 16 meter per second. Average speed is equals to total displacement upon total time taken is equals to 0 upon 25 is equals to 0 meter per second. Now another one, an aeroplane taxis on the runway for 30 seconds with an acceleration of 3.2 meter per second before taking off. How much distance would it have covered on the runway? Given acceleration is equals to 3.2 meter per second square. Time is equals to 30 seconds. U is equals to 0. S is equals to find out. And S is equals to ut plus half of at square. Therefore, 0 into 30 plus half into 3.2 into 30 into 30. So that will be equals to 0 plus 1.6 into 900. So therefore, 1.6 into 900 is equals to 1440 meters. A kangaroo can jump 2.5 meter vertically. What must be initial velocity of the kangaroo? Given A is equals to 9.8 meter per second square, S is equals to 2.5 meter, V is equals to 0, U is equals to question mark. So therefore V square is equals to U square plus twice of AS. Here V is equals to 0 is equals to U square plus 2 into minus 9.8 into 2.5. Here we'll take the 9.8 into the minus because it is negative acceleration in the opposite direction of the gravitational force. So therefore 0 is equals to U square minus 49. So therefore U square is equals to 49. So therefore U is equals to 7 meter per second when we will take the square root on both the hand sides. A motor boat starts from rest and moves with uniform acceleration if it attains the velocity of 15 meter per second in 5 seconds. Calculate the acceleration and distance travelled in that time. Initial velocity is equals to 0. Final velocity is equals to 15 meter per second and time t is equals to 5 seconds. Acceleration is equals to question mark. From the first equation of motion, A is equals to V minus U upon T. So 15 minus 0 upon 5. So 15 upon 5 is equals to 3 meter per second square. From the second equation of motion, the distance covered will be S is equals to ut plus half of at square. S is equals to 0 into 5 in plus half into 3 into 5 into 5. S is equals to 0 plus 75 upon 2. That will be equals to 75 upon 2. So here 37.5 meter. Newton's laws of motion. A static object does not move without the applying of a force. Fruits on a tree fall down when its branches are shaken. An electric fan keeps on rotating for some time even after it is stopped. If we took reason for above, we realize that objects have same velocities. Newton's first law of motion describes this very properly. Therefore, it is called as law of inertia. Balanced and unbalanced force. You must have played tug of war. So long as the force applied by both the sides are equal, that is balanced, the center of rope is static in spite of the applied force. On the other hand, when the applied force becomes unequal, that is unbalanced, a net force gets applied in the direction of the greater force and the center of rope shifts in that direction. Newton's law. An object continues to remain at the rest or in the state of uniform motion along a straight line unless an external unbalanced force acts on it. This means what? कोई भी ऑब्जेक्ट उस वक्त तक अपनी पोजीशन को चेंज नहीं कर सकता है जब तक कि उसके ऊपर एक्सटर्नल अनबैलेंस्ड फोर्स का अप्लाई नहीं होता है। मतलब सिंपली अगर आपको किसी चीज़ को उठाना है, रखना है, तो वो ऑब्जेक्ट के ऊपर आप जब तक अनबैलेंस फोर्स अप्लाई नहीं करेंगे आप उस चीज़ को उठा नहीं सकते, उसको रख नहीं सकते, उसको धक्का नहीं मार सकते, उसको खींच नहीं सकते। तो इस तरह से जब भी आप फोर्स अप्लाई करते हैं ये फोर्स जो है अनबैलेंस्ड फोर्स होती है और इसी वजह से आपका जो है एक्शन परफॉर्म होता है। सिंपल जो है हम फोर्स को क्या कहते हैं? इट इज़ अ फिजिकल क्वांटिटी दैट परफॉर्म्स द एक्शन। तो आपको एक्शन परफॉर्म करने के लिए फोर्स का होना बहुत ज़रूरी है, लेकिन ये फोर्स न्यूटन के मुताबिक किस तरह से होना चाहिए? अनबैलेंस्ड फोर्स होना चाहिए। यानी किसी भी ऑब्जेक्ट्स पर अगर आप फोर्स लगाते हो तो वो ऑब्जेक्ट पर जो है अनबैलेंस्ड एक्सटर्नल फोर्स का एप्लीकेशन होता है, तभी वो ऑब्जेक्ट्स अपनी पोजीशन को चेंज करते हैं। चाहे वो मोशन में हो, अगर वो मोशन में है तो वो अपनी मोशन को स्टॉप कर देंगे, अगर वो स्टेट ऑफ रेस्ट में है, यानी वो मूव नहीं कर रहे हैं और आपकी एप्लीकेबल फोर्स अनबैलेंस्ड है, एक्सटर्नल है, तो वो अपनी मोशन को स्टार्ट कर देंगे या फिर उनका डायरेक्शन भी चेंज हो सकता है। Explanation. When an object is at rest on its uniform motion along a straight line, it does not mean that no force is acting on it. By they can cancel one another so that the net force is zero. मतलब यहाँ पर क्या बोला है? Actually in this case, when we will talk about unbalanced force, it is a case of pairs of two forces. यानी ये जो केस है ये टू फोर्सेस के बारे में है कि दो फोर्सेस एक दूसरे के ऊपर काम करती है। एक दोनों फोर्सेस का अपोजिट डायरेक्शन होता है, जैसे एक फोर्स जो है अगर आपने लगाए तो ऑब्जेक्ट भी आपके ऊपर उतनी ही फोर्स लगाता है, लेकिन वो ऑब्जेक्ट की फोर्स जो है आपकी फोर्स से कम होती है, इसीलिए आपका एक्शन परफॉर्म होता है। इसका मतलब ये नहीं है कि वो ऑब्जेक्ट के पास फोर्स नहीं है, ऑब्जेक्ट के पास फोर्स है लेकिन वो आपकी फोर्स की इक्वल क्वांटिटी में नहीं है और उसका डायरेक्शन जो है आपकी फोर्स के डायरेक्शन में है, इसीलिए जो है आपका फोर्स जो है अनबैलेंस्ड फोर्स होता है और कोई भी एक्शन परफॉर्म होता है। Newton's first law explains the phenomena of inertia. Now, what is meant by inertia? Inertia is the inherent property of an object by which it tends to remain in its state of rest, state of motion or in the state of सेम डायरेक्शन। मतलब ये इनर्शिया एक ऐसी प्रॉपर्टी है ऑब्जेक्ट की जिसमें हर ऑब्जेक्ट अपने आप में जो है एक काबिलियत रखता है कि या तो वो अपनी स्टेट ऑफ मोशन को कंटिन्यू करे, या तो वो अपनी स्टेट ऑफ रेस्ट को कंटिन्यू करे, या फिर वो अपनी स्टेट ऑफ मोशन डायरेक्शन को कंटिन्यू करे और फिर इस तरह से जो है वो अपने आप को मेंटेन करता है। ये प्रॉपर्टी इनर्शिया कहलाती है। ये इनर्शिया की प्रॉपर्टी बहुत इंपॉर्टेंट है क्योंकि न्यूटन का फर्स्ट लॉ इसी प्रॉपर्टी पे डिपेंड करता है। That is the inability of an object to change its state of motion on its own. It also explains the unbalanced force which cause a change in the state of an object at rest or in uniform motion. Now let us go with the Newton's second law of motion. Momentum, that is P. The effect of an object is striking another object depends upon both on the mass of the former object and its velocity. This property is related to the mass and velocity of the striking object. This property was termed by the Newton as momentum. Momentum has magnitude as well as direction. Its direction is same as that of the velocity. In SI system, the unit of momentum is kilogram meter per second, while in CDS system it is gram centimeter per second. Momentum is the product of mass and velocity of an object. मतलब ये कि कोई भी ऑब्जेक्ट अगर स्टेट ऑफ मोशन में है तो उसका अपना खुद का मास और मोशन की वजह से उसे अटेन होने वाली वेलोसिटी दोनों मिलकर हमें मोमेंटम बताते हैं। मतलब ये कि अगर कोई ऑब्जेक्ट है तो उसका अपना खुद का मास मतलब यानी उसका actual quantity of matter present in the object and because of the motion what the type of the velocity it attains, that together makes that mass and velocity together makes the momentum. So this momentum is represented with the symbol P and its relationship can be written as P is equals to m into v. The momentum is a vector quantity because it has its direction. So here the Newton's law, the rate of change of momentum is directly proportional to the applied force and the change of momentum occurs in the direction of the force. Explanation. Suppose an object of mass m has its initial velocity u. When a force F is applied in the direction of its velocity for time t, its velocity becomes v. The initial momentum of an object is equal to mu. The final momentum after time t will be mv. So therefore, the rate of change of momentum is equals to change in momentum upon time. So therefore, the rate of change of momentum is equals to mv minus mu upon t. That will be equals to m into bracket v minus u upon t. Therefore, m is equals to the momentum is equals to m into a. According to the Newton's second law of motion, the rate of change of momentum is proportional to the applied force. Therefore, m is equals to m is directly proportional to the f. So therefore, f is equals to k into ma, whereas the k is the constant of proportionality and its value is 1. So f is equals to m into a. Force is F. In the SI system, the unit of force is Newton, while in the CGS system, the unit of force is dyne. Consider two objects having different masses which are initially at rest. Suppose a force x at time t on both objects. The lighter object starts moving faster than the heavier objects. However, we know that the rate of change of momentum F in the both object is same. Newton's third law of motion. We have learnt about force and its effect on an object through the Newton's first law and second law of motion. Force is a reciprocal action between two objects. Forces are always applied in pairs. When an object applies a force on another object, the latter object also simultaneously applies a force on the former object. The force between two objects are always equal and opposite. The force between two objects are always equal and opposite. The force applied by the first object is called action force, while the force applied by the second object on the first object is called reaction force. Newton's law of motion will be every action force has an equal and opposite reaction force. Some more characteristics. Action and reaction are the terms that expresses force. This force acts in pairs. One force cannot exist by itself. Action and reaction forces act simultaneously. Action and reaction force act on different objects. They do not act on the same object and hence cannot cancel each other's effect. Laws of conservation of momentum. Suppose an object A has a mass m1 and its initial velocity is 1. So an object A has mass m1 and its initial velocity u1. Similarly, the object B has the mass m2 and its initial velocity is u2. According to the formula for the momentum, A is equals to m1 into u1 and the initial momentum of B will be equals to m2 into u2. Suppose these two objects collide together, so let the force A due to B be the F1. This force will cause acceleration in A and its velocity will be v1. So momentum of A after collision will be m1 v1. According to the Newton's third law of motion, A also exerts an equal force on the B but in the opposite direction. This will cause a change in the momentum of B. So if its velocity after collision will be v2, so the momentum of B after collision will be equals to m2 into v2. If F2 is the force that acts on the object B, so therefore F2 is equals to minus F1 because F in the opposite direction of the each other. So therefore m2 into a2 is equals to m1 into a1. Therefore m2 into v2 minus u2 upon t is equals to minus m1 into v1 minus u1 upon t. Therefore, A is equals to V minus U upon T. Therefore, M2 into U2, V2 minus U2 is equals to minus M1 into V1 minus U1. Therefore, M2 V2 minus M2 U2 is equals to minus M1 into V1 plus M1 into U1. Therefore, M2 V2 plus M1 V1 is equals to M2 U2 plus M2 U2. Thus, if no external force is acting on two objects, then their total initial momentum is equal to their total final momentum. This statement is true for any number of objects. Therefore, when two external forces act on two interacting objects, the total momentum remains constant, it does not change. This is corollary to Newton's third law of motion. Explanation: the momentum is unchanged after the collision. The momentum gets redistributed between the colliding objects. The momentum of one object decreases while that of the other increases. Thus, we can also state this corollary that when two objects collide, the total momentum before collision is equal to the total momentum after collision. In order to understand this principle, let us consider some examples, that is, firing of a bullet from the gun. When a bullet of mass m1, its velocity becomes v1 and its momentum becomes m1 into v1. Therefore, firing the bullet, both the gun and the bullet are at rest. Hence, the total momentum initially is 0. According to the above law, the total final momentum also has 0. Thus, the forward moving bullet causes the gun to move. Backward motion of gun is called its recoiling. The velocity of recoil v2 is such that m1 v1 plus m2 v2 is equals to 0, or v2 is equals to m1 into m2 into v1. As the mass of the gun is much higher than the mass of the bullet, the velocity of gun is much smaller than the velocity of bullet, and that of the gun are equal and their direction are opposite. Thus, the total momentum is constant. The total momentum is also constant during the launch of a rocket. Solved examples. The mass of cannon is 500 kilograms and it recoils with a speed of 2.5 meters per second. What is the momentum of the cannon? Given the mass of cannon is 500 kilograms, recoil speed is equals to 0.25 meters per second. Momentum is equals to m into v. Therefore, 500 into 0.25 meter, so is equals to 125 kilograms per meter per second. Two balls have masses of 50 grams and 100 grams, and they are moving along the same line in the same direction with velocity of 3 meters per second and 1.5 meters per second respectively. They collide with each other, and after the collision, the first ball moves with a velocity of 2.5 meters per second. Calculate the velocity of the other ball after the collision. Given the mass of first ball is equals to m1 is equals to 50 grams is equals to 0.05 kilograms. The mass of second ball is equals to m2 is equals to 100 grams is equals to 0.5 kilograms. Initial velocity of the first ball is equals to u1 is equals to 3 meters per second. Initial velocity of the second ball is equals to u2 is equals to 1.5 meters per second. Final velocity of the first ball is equals to v1 is equals to 2.5 meters per second. Final velocity of the second ball is equals to v2 is equals to question mark. According to the law of conservation of momentum, total initial momentum is equal to total final momentum. Therefore, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Therefore, 0.05 into 3 plus 0.1 into 1.5 is equal to 0.05 into 2.5 plus 0.1 into v2. Therefore, 0.15 into 0.15 plus 0.15 is equals to now the summary. Distance is the length of actual path traveled by an object in motion while going from one point to the other, whereas the displacement is the minimum distance between the starting and finishing points. The displacement that occurs in unit time is called velocity, depends upon speed as well as direction. If an object covers equal distance in equal intervals of time, it is said to be in the state of uniform motion. When it covers unequal distance and equal intervals of time, it is said to be in the non-uniform speed or a non-uniform motion. The rate of change of velocity is called acceleration. Acceleration may be positive, negative or a zero. Three equations of a motion. Number 1, v is equals to u plus at. Second, s is equals to ut plus half of at square. And third, v square is equals to u square plus twice of as. When an object is moving with a constant speed along a circular path, the motion is called as uniform circular motion. Newton's first law of motion, the law of inertia, an object continues to remain at rest in a state of uniform motion along a straight line unless an external unbalanced force acts on it. Newton's second law of motion, the rate of change of momentum is proportional to the applied force and the change occurs in the direction of a force. Momentum is a vector quantity. It is the product of mass and velocity. Therefore, P is equals to n into V. Newton's third law of motion. Every action force has an equal and opposite reaction force which act simultaneously. When two objects collide, the total momentum before collision is equal to the total momentum after collision. Therefore, m2v2 plus m1v1 is equals to m1u1 plus m2v2. Here I'm ending up. Before ending up, I want to request you to like and subscribe the channel. Jazakallahu khair. Assalamu alaikum.